Ever pondered about the origin of the universe? How did it all begin? Let's delve into the Big Bang Theory, a concept that has captivated scientists and thinkers for generations. This theory is the most widely accepted explanation for the birth of our universe. Imagine, if you will, a point of incredibly high temperature and density, smaller than an atomic particle, teetering on the brink of existence. This point, this singularity, contained all the energy that would ever exist, all the matter that would ever be, all compressed into an infinitesimally small space. Around 13.8 billion years ago, give or take a few million, something extraordinary happened. This singularity exploded. Not in the way you might think, like a bomb or a star-going supernova, but in a way that's much harder to envision. It expanded. In a fraction of a second, faster than the blink of an eye, this tiny point began to grow exponentially. It wasn't an explosion into space, but an explosion of space. The universe as we know it was born. From this fiery, chaotic birth, all the energy that would ever exist spilled forth. This energy then began to cool and expand, setting the stage for the formation of atoms, stars, galaxies, and eventually, life itself. The Big Bang Theory isn't just about that initial explosion though, it's a theory that continues to evolve and grow, just like the universe it seeks to explain. It's a story of creation, of expansion, of the evolution of the cosmos from a hot, dense state to the vast, complex system we see today. It's mind-boggling to think that every star you see in the night sky, every planet, every galaxy, and even the vast emptiness of space itself, originated from that single, dense point. So, our universe is a result of a colossal explosion. But what happened next? Imagine a clock ticking, but this clock is for the universe. What happened in the first few seconds? Let's delve into the mystery of the early stages of our universe's formation. A timeline so surreal it will leave you awestruck. In the beginning, the universe was incredibly hot and dense, so much so that it was impossible for particles to form. It was a sea of pure energy, a boiling, bubbling cauldron of light and heat. But as the universe expanded, it began to cool. And it's within this cooling process where our story truly begins. As the universe cooled, the energy started to morph into something tangible, something we could touch and feel. It was the birth of matter as we know it. The first particles to form were protons and neutrons, the building blocks of the atomic nucleus. These protons and neutrons would eventually come together, forming the nucleus of the first hydrogen atoms. But the universe wasn't done yet. As it continued to cool and expand, the electrons entered the party. Electrons are tiny particles that whirl around the nucleus, completing the atomic structure. They are the very reason why we can touch and feel things, why electricity flows and why chemistry happens. The universe was now a soup of these fundamental particles buzzing around in the cosmic expanse. And yet, all of this happened in just a few seconds. Imagine that. The birth of matter, the creation of protons, neutrons, and electrons, all in the blink of an eye. It's a testament to the incredible energy that existed at the start of the universe, and a reminder of the mind-boggling speed at which our universe was born. But this was just the beginning. The universe was still in its infancy, with much more to come. It was far from the cosmos we know today, filled with galaxies, stars, and planets. But it was on its way. The universe was expanding and cooling, which led to something extraordinary. And that extraordinary something? Well, that's a story for our next scene. As the universe cooled down, the stage was set for the creation of atoms. But how? Well, let's imagine the universe as a great cosmic kitchen. Initially it was too hot, too energetic for any real cooking to happen. But as it cooled down, things started to change. Around 3 minutes after the Big Bang, the temperature had dropped to a point where protons and neutrons could start coming together. This was the beginning of nuclear fusion, a process in which two atomic particles combined to form a heavier nucleus. In this cosmic kitchen, the first dish served was hydrogen, the simplest of all atoms, with just one proton and one neutron. But the universe wasn't satisfied with just hydrogen. It had a more complex recipe in mind. As the universe continued to cool, some of these hydrogen atoms started to fuse together, forming helium, an atom with two protons and two neutrons. At this point, the universe was a soup of hydrogen and helium atoms, but it was still too hot for these atoms to combine and form molecules. It took hundreds of thousands of years for the universe to cool down enough for this next step to happen. And when it did, magic happened. The hydrogen atoms started to come together, forming hydrogen molecules. These are the simplest and most abundant molecules in the universe, and they set the stage for the formation of more complex molecules. Meanwhile, Helium, being a noble gas, preferred to stay alone. But don't underestimate its importance. It played a crucial role in the formation of stars, which we'll get into in the next scene. So there you have it. The universe, from a hot, dense point, cooled down and transformed into a vast expanse filled with atoms and molecules. This was the universe's way of setting the table, preparing for the grand feast of creation that was to come. With atoms and molecules in place, the universe was ready for the next big step. With atoms and molecules present, the universe was not a dark place anymore. Stars and galaxies began to form. As the universe cooled down, the omnipresent hydrogen and helium atoms started to gravitate towards each other due to the inherent forces of attraction. These gatherings of atoms were the humble beginnings of what we now know as stars. These atoms did not just randomly clump together. The process was a slow and steady one, as gravity patiently pulled these atoms closer and closer. As these particles of hydrogen and helium huddled together, the pressure in the core of these gatherings started to increase, generating an immense heat. This high pressure and temperature triggered nuclear fusion, a process in which hydrogen atoms combined to form helium, releasing a tremendous amount of energy. This energy, in the form of light and heat, is what makes a star shine. This process of star formation was not an isolated event. It happened simultaneously in multiple pockets of the universe. Some of these pockets had more atoms than others, and as a result, they formed bigger stars. But the story doesn't end there. These stars, once formed, didn't exist in isolation. They were part of a grander scheme, a cosmic dance choreographed by gravity. Clusters of these stars began to form, drawn together by the same force that had created them. These clusters of stars, bound together by gravity, were the precursors to galaxies. Galaxies, like stars, vary in size and number of stars they contain. Some galaxies, like our own Milky Way, contain hundreds of billions of stars. Others are smaller, containing just a few billion stars. But regardless of size, each galaxy is an intricate network of stars, gas, and dust, all interconnected and bound by gravity. So there you have it. From a universe filled with atoms and molecules, gravity sculpted stars and galaxies. These celestial bodies, with their light and energy, transformed the universe from a dark void into a cosmic wonderland. Stars and galaxies were lighting up the universe, but what about the planets? From a fiery, dense point to a universe filled with stars and galaxies, the stage was finally set for the formation of planets and life. As stars came into existence, they were accompanied by an entourage of dust and gas. This cosmic dust, swirling around the newborn stars, began to collide and stick together, forming larger and larger clumps. These clumps eventually grew into what we now recognize as planets. This process, known as accretion, took millions of years, but it was a crucial step in the grand story of our universe. Now, not all planets are created equal. Some, like Jupiter and Saturn, are gas giants, composed primarily of hydrogen and helium. Others, like Mars and Venus, are rocky, terrestrial planets. But one planet, our Earth, had just the right conditions to foster something truly extraordinary: life. Let's take a moment to appreciate how remarkable this is. For life as we know it to emerge, a planet needs the right ingredients. It needs a source of energy, like the sun. It needs water, as all known organisms require it. It needs the right kind of atmosphere, with the right balance of gases. And it needs time, lots of it, for complex organisms to evolve. Earth, as it turns out, had all of these things. But how did these conditions come to be? Well, it's a combination of many factors. The Earth's distance from the sun, its magnetic field protecting it from solar radiation, the presence of water, and the composition of its atmosphere, all played a part in creating a hospitable environment for life. Life on Earth started out simple. Single-celled organisms, barely visible to the naked eye, were the first to inhabit our planet. But with time, these simple organisms evolved into the diverse array of life forms we see today, from plants and animals to humans. From a tiny, hot, and dense point to a vibrant universe teeming with life, the story of the universe is indeed awe-inspiring. So we've journeyed from the birth of the universe to the formation of life. Let's recap what we've learned. We started our cosmic journey with the Big Bang, that singular, fiery instant when the universe itself was born. From this point of singularity, we saw the universe rapidly expand, cooling down and giving rise to fundamental particles. As the universe continued to cool, these particles came together to form atoms, the building blocks of matter. Then we witnessed the birth of stars and galaxies, massive celestial bodies composed of these very atoms. These stars lived and died, their explosive ends scattering heavier elements across the cosmos. And from this stardust, planets, including our own, were born. Finally, we explored the formation of life, the ultimate result of this cosmic journey. From the simplest single-celled organisms to the complex beings we are today, life is the culmination of billions of years of cosmic evolution. The universe, with its vastness and complexity, started from a single point. It's a story of expansion, cooling, and creation, a testament to the incredible power of nature.